Aloha, Rich Alverson here. This is ITS128, and today's the last day of September. Let me share my screen. And this is the syllabus here, and we are like around here. No, September. Yeah, so we are in the. Oh, I guess we are starting chapter 5. Okay, so but we aren't finished with chapter 4 yet. So we only got up to, if we look at the playlist, we've only gotten up to lab 4.14. And so I think today I'd like to just zip through the rest of the labs. And then we're having class again Friday, tomorrow. Let's see. Announcements. Yeah, tomorrow we're having class again. So tomorrow we'll start on the next chapter. All right. So let's go to. I was just checking here, and it looks like half of you have done the. Half of you have done all the labs. And so I don't know if it's the same half, could be. But let's start with lab 4.15. And I'm gonna open up see, this is 128. So I'm gonna open up a little editor thing here, just so I can let's see, let me open up here's my 128 folder, and I have a, well, it doesn't matter. Okay, so let me just open up a program here, and then open up a command line. And oh, it looks like this was 4.14, this one here, because we're supposed to read in a red color and a green color and a blue color, figure out what the smallest one is, and then subtract that smallest amount from all the colors, and then that takes out the gray or whatever. So let's start over again. And let's call this one, save as, let's call it 4.15.py. How's that? And it is, find the smallest number. Write a program whose inputs are 3 integers and whose output is the smallest of the 3 values. So your program asks for 3 integers, and then it outputs the smallest one. Okay, so there's lots of different ways that we can do this program. And I tell you what I'm going to do is I'm going to write a program to print out the largest one. And then from that, you should be able to easily figure out how to change it to make it so it prints out the smallest one instead of the largest one. Okay, so first of all, I have to read in the number. So I'm going to read in these three integers here. 3 integers. So I'm going to say I1 int 1 is equal to integerize the input of asking enter an integer. Now, of course, you're not going to have this enter an integer for your solution here, because you don't want it to print out these words. But for our little program that we're running here, I'm gonna print that out so I know what's going on. So I got to read in 3 of these. So let me 3 of them. Okay, so I've got three integers that I read in. And now I can just do this real brute force. So either int 1 is going to be the largest, or int 2 is going to be the largest, or int 3 is going to be or int 3 is going to be the largest. It's not going to be anything other than that. So let's just test all three of them. If int 1 is greater than int 2, and int 1 is greater than int 3, if int 1 is greater than int 2 and int 1 is greater than int 3, then we know that int 1 is the largest. Then print what are we supposed to print here? Oh, just the largest, just print it out. Okay, so print, well, I'm gonna do this. Int 1, comma, is the largest. Now remember, your program's supposed to do the smallest. Okay, so this, if int 1 is bigger than int 2 and int 1 is bigger than int 3, then int 1's the largest. So it prints that out. And then, okay, so it's either going to be that option. So I don't really need to do an elif, because because we're just going to do three mutually exclusive options. So I'm going to put another one there and another one there. Okay. So for the second one, I'm going to test if int 2 is the largest. So I'm going to say if int 2 is greater than int 1 and int 2 is greater than int 3, then int 2 is the largest. And for the third one is if int 3 is greater than int 1 and int 3 is greater than int 2, then int 3 is the largest. Now we actually have a problem here, and that is what happens if they're equal. So I think we want to cover that case by just doing this. If int 1 is greater than or equal to int 2, and int 1 is greater than or equal to int 3. Well, let's see, let's test this first. Okay, so I'm just going to save this, and it's 15. It's 15. So let me do CD OneDrive desktop ITS128, and so here we are, and it's this is the one I'm going to run. So I'm going to say Python 4.15.py, and it asks enter an integer, and I'll enter 5, 10, 15, and it prints out 15 is the largest. How about 15, 5, 10? Yes, 15 is the largest. Oh, okay. Well, anyway, so you actually should test all the cases. Well, of course, we have the problem if we have 15. Oh, oops, let's run this again. We have 15, 15, 15. And what does it do is it doesn't print anything because that was not any of these cases. Well, let's just include if int 1 is greater than or equal to int 2 and int 1 is greater than or equal to int 3, then int 1 is the largest. Otherwise, if okay, let's do that, and then let's do this one, int 3 and int 3. This is also going to cause a problem, because if we do the same 15, 15, 15, what happens? It prints out 3 times. So let's do the elif. I think let's do elif. Elif, because then that'll ensure only one. That'll ensure only one will print out. 15, 15, 15. See? Did I say this? No, I didn't save it. That's the problem. 15, 15, 15. Just one prints out. In fact, it's the first one that prints out. So, anyway, so I've taken you through that, and you should be able to write the answer now to this one, because this one is looking for the smallest. This one does the largest. There's other ways that you can do this, and that is, it's like you can do if int1 is greater than int2, then that's not a word in this language. If int1 is greater than int3, then you print int1 is the largest. Otherwise, you can do LF. This means that int, if this is true, but this is not true, then this means that int3 is not, or no, that means that int3 is greater than int1. If this is wrong, if this is false, then that means that int3 is greater than int1. And if int3 is greater than int1, and int1 is greater than int2, then int3 is the largest. So print int3 is the largest. Otherwise, if int else, else, let's try it with just a bunch of if else then. Okay, so if int1 is greater than, if it's not true, then that means int2 is greater than int1. So if then let's look at if int2 is greater than or equal to int3, then so we have the case of int2 is greater than int1 and int2 is greater than int3. So that means int2 is the largest. Otherwise, we have that int2 is greater than int1, but int3 is greater than int2. So that means int3 must be the largest. See, I don't know why I even started this. So if int1 is greater than int2, then otherwise int2 is greater than int1. But I don't have the case where if int3 is greater than it's, well, anyway. I don't think I'm going to finish this. Okay. I mean, I kind of went down this path. You can see the point that I was going to make is that there's several different solutions for these kinds of problems. There's several different solutions, and we don't even have to use this structure either. There's other structures that we can use. But anyway, I think you have enough to solve this problem and you understand the ideas. So let me just move on to the next one. Here, I don't want to spend too much time. I'd like to get through all of these actually. I'd like to get through all these today. So let's look at the interstate highway numbers. Okay, this is a really long one. Okay, so for this one we have we're supposed to figure out by what the number is. Okay, this is the interstate highway system in on the mainland. And you know, there are these the interstate highway system are interstate highways that are funded by the federal government, and there's a bunch of rules about them, how they, and this was the Eisenhower administration who started this, and so they made a bunch of freeways across the freeways. You know, there's no stop signs on freeways, right? There's no driveways, there's no houses off freeways or anything, and so you can go fast. And the way the numbering system works is the vertical freeways, the freeways that go north south, those end in those are odd numbers. Those are odd numbered freeways. And the freeways that go east and west are even numbered freeways. Okay, and then there are, okay, and those go from 1 to 99. Okay, now there's also like splinters or branches off of freeways where they might go around a town or something, like in Minnesota, for example. I'm from Minnesota, and we have Interstate 90. Interstate 90 is the highest. Well, okay, so Interstate 90 is a freeway that goes like, it's the northern, it's kind of like the northernmost main freeway that goes, you know, from Seattle to Maine or something. And then and that goes through, I think, Chicago, or no, it goes through like southern Minnesota. But then there's 94. That's an east-west, and that goes, that's horizontal, and that goes through the Twin Cities of Minneapolis and St. Paul. So 94 goes right through the Twin Cities. But then there's this 494 that is sort of an offspring, and that goes south around the cities, and then connects back up again with 94, you know, on the other side. And 694 goes north around the cities and connects back up again. So if you're just traveling through, then you will probably want to take 494 or 694 because it goes around the city. But if you're going into the city, you know, you take 94, it goes right into downtown Minneapolis, and then goes a little bit further, it goes right into downtown St. Paul. And so that's how that works. Anyway, so we're supposed to figure out, and 290 is like, it's an auxiliary, and I mentioned that. And so how does this work with Hawaii? Well, it's all different here. You know, we have H1 and H2, and then we have H201, is it? H201, and that's supposed to be one of these auxiliary things. I thought it should have been like 2H1 or something, but anyway, so what this assignment is we're supposed to read in a number, and it's supposed to display out what it is. And so it's a great big bunch of if-then statements. So first we're going to read in a number. Tell you what, I'm just going to write it. Okay, first we read in a number, and then the first thing is we have to test to see if it's valid or not. So I'm going to say if highway number is less than 1, or highway number is greater than 99. Oh, I guess it's going to be 999 because we're going to do all the 3-digit ones too. Yeah, like that. Okay. If it's greater than that, 999, then there's an error. Print. There's an error. And let's do highway number is this supposed to be like an underscore there? Is not valid. Whatever, you gotta make it print right. Otherwise, we can, continue on. So first of all, let's see if it's an auxiliary or not. So if it's greater than 99, if it's 100 or more, then it's an auxiliary. So let's do that. If highway number is greater than 99, then I'm just going to print out here, I'm just going to do print kicks. I'm going to come back to this. I'm going to print highway number is auxiliary. I'm just going to print that out, come back to it later. So that's if it's greater than 99. Okay, it's valid. So so otherwise it's less than 99. So it's else it's less than 99. And we can say print highway number is a main, I guess it's a main, whatever, is a primary, is primary. Okay, I'm just going to print that now, and I'm going to come back to it later. Okay, so that takes care of that. Now I should test to see if it's even or odd. So and I guess that'll work. If highway number mod 2, if mod 2 is 0, then we know it's even. So if it's equal to 0, then we know it's an even one. Then I'm going to say print highway number is east-west. Oops. Otherwise, print highway number is north-south. Okay, so I'm gonna just test this now, and I'm gonna say I'm gonna keep it in development mode, and I'm gonna try, first I'm gonna try 0. You should try all the 1. Okay, 1 is primary, 1 is north-south, and that's correct. 99. Primary north-south. 98. Primary east-west. 2 is primary east-west. What about 100? Auxiliary east-west because it's even. Yes. And so 101 is, so anyway, okay, so this looks like it works. 1000, of course, is going to not work. And so now we want to make it so we have to do, when it's an auxiliary, we want to grab off, we want to figure out what that is. So we want to say if it's an auxiliary, here we go. We want to grab it off. So we want to say, primary. Let's make a new variable called primary, and that is going to be the lower 2 digits equals highway number. 2 lower 2 digits divided by 100, integer 100. Okay, that'll give me the lower 2 digits, right? No, no, it won't. Mod 100. That gives me the lower two digits. Is an auxiliary to primary. And I'm going to say end equals nothing. And otherwise it's primary and equals nothing. And then if it's odd, and I'm going to say what am I supposed to say? Going east-west, and this can be going north-south. Okay, this looks better. So now when I run this, so if I go 94 is where 94 is primary going east-west, but 494 is an auxiliary going east-west. An auxiliary to 94 going east-west. So anyway, yeah, so that's so that should get you started. You should be able to tidy this up and make that work. Okay, so what's the next one? Lab seasons. No, seasons. Okay, so this program takes a date and outputs what the season is. So the input is a string to represent the month and an integer to represent the year. So you're going to input something that looks like this, and it's going to output what the season is. And this is the rules for the seasons. Okay, so we're inputting a month and we're inputting a day. So let's just type some code in here. I'm going to say if a month, input month, is equals January. If input month is equal to January, then we are does it have to validate the it's got to validate the actual month and day. Yeah, sure. What does it say about February? Okay. All right. So so if it's January and we got to validate the dates, right? And input day is greater than or equal to 1, and input day is less than or equal to 31. If that's all true, then we're in winter time. Then what? Print winter. Okay, print winter. Well, you can make this easier. You can go if input day is less than 1. I don't need parentheses. That's right. Parentheses. If input day is less than 1, then print invalid. Yeah. Okay. Else Okay, I've made my job a lot easier because I just have to go. Do this, LF. So that LF input month is equal to January and input day is less than 31. Then I'm going to print winter. LF. And I'm just going to okay, February is all winter. So this is okay, February 29. Let's do 29. Then it's winter. LF March, and the input day is less than or equal to 20. If this is true, then we're still in winter. Otherwise, if it's less than 31, then it is spring, right? Oops, gotta make sure we're underscoring here. And then if we are, that's March, and April is all spring. So I can just do something that looks like this. No, it doesn't. April is all spring. April. How many days are in April, January, February, March, April? 30 only. 30 days in April. This is spring. May is nothing yet, so May is 31 days. January, February, March, April, May is 31 days. And do we split up in May here? No. Oh, May is all March, spring. And then, June though, yes, spring. Okay, so up to June 30th. So month is June, and the input day is less than 21. So less than or equal to 20. What's going on? Yeah, 20. Summer, June 21. If it's less than or equal to June 21, less than or equal to 20, it is still spring. Otherwise, if it's June, what happened to, oh, ran out of May. June, and it's less than or equal to 31, then we're in summer. Okay, so anyway, you know, you should be able to finish this. Let's see how this looks. So I'm going to say February 15. says winter. Okay, March 15. March 25. Okay, anyway, and of course you should test the boundary conditions. You should test, the boundary conditions. Anyway, so you should be able to continue this and get and at the very end you should put when you're all done you should put else print invalid. Why? Because that means that you typed in the month wrong, or you had a date that was greater than 30 or 29 or whatever. So something it wasn't caught here, but it also was not caught in any of these. And so these should cover all the dates all the way to December 31st, and then after that you're going to have it invalid. So anyway, that is how. So you should be able to finish that. All right, what time is it? It's 4:07. Good. Okay, so what's next? Exact change. Okay, write a program with total change amount as an integer input, and the output the change using the fewest coins, one coin type per line. The coin types are dollars, quarters, dimes, nickels, and pennies. Use singular and plural coin names as appropriate. In other words, say 1 penny versus 2 pennies. Okay, so all right, so we're going to input. So first, we're going to input. We have to read in. So I'm going to read in change. Change equals input, an integer input of something. So I'm just going to do this, and that way I won't. It's not going to ask a question, but I'll just run it down here. Okay, so there's the change, and I want to say first of all I got to check to see it's greater than 0. If change is less than, do I do that or do I just? All right, less than or equal to 0. Let's say no change. Less than or equal to 0. Print no change. Otherwise, okay. So first I'm gonna so it's possible they type in more than $1. So the first thing I'm gonna do is I'm gonna grab out all the dollars. I'm going to grab out all the dollars, and then there's going to be some change. Okay, so I'm going to say dollars equals whatever the change is divided by integer divide by 100. Okay, so that's going to give me, so if it's like $5.23 and I divide by 100 and I just take the integer part, I get 5, and that's what I want. So that's how many dollars it is, and I'm going to have to figure out what okay, so I have figured out what the dollars part of change is. Now I have to subtract out the dollars part because I've set that aside. So what is left? Well, actually, what is left is this: change equals change mod. Okay, so that's what's left. Next, I want to try to see how many quarters there are. Do we have half dollars? Do they make half dollars anymore? I guess we're not dealing with half dollars. Guess we don't make them. So I'm going to do quarters. How many quarters are there? equal, that's going to be change integer divide 25. So if there's like 80 cents, changes like 80 cents, then 80 divided by 25 is going to be 3, and what's going to be left over is 75, you know, and then what's going to be left over is 5 cents. But anyway, so that's what quarters is. And then we want to grab what's left out of that, and that's what change is now equal to now, equals change mod 25. And then we're going to try to grab out dimes. So dimes equals change integer divide 10, and change equals change mod 10. So that's going to give us something with that may be a nickel and then some pennies, up to 4 pennies. So let's do nickels equals change integer divide for 5 to get how many nickels. It's only going to be 0 or 1. And so change equals change mod 5, and that's how many pennies we have. Okay, so that's how many pennies there are. Okay, and I guess I don't really need these spaces here. All right, so next I want to print out all these things out. So I'm going to do dollars. So I'll start with dollars, and I'll say I guess I should only do this if dollars is if dollars is greater than 0. I'm going to do it this way. If dollars is greater than 1, then print out dollars. And I guess I don't want to, I guess I'm going to print out, I guess I'm going to print this all out on one line. So I'm going to do n equals, I guess, this. Okay, so if, can I do this? Oh, nice. Okay, if dollars is greater than 1, then I print out something dollars. Otherwise, dollars, if dollars equals 1, then print out dollars, dollar. How's that? Okay, so that's dollars. The next is if quarters, dimes, nickels. Okay, so if quarters and dimes, oh, what am I doing? Quarters, no caps. Dimes, nickels. Okay, so nickels, nickel, dimes, what happened here? Dimes, dime, quarters, dollars. Okay, so if dollars is greater than 1, it prints dollars. Otherwise, if dollars is equal to 1, it just prints dollar. If quarters is greater than 1, it prints quarters. Otherwise, if it's equal to 1, it just prints quarters. Same with dimes. Same with nickels. Oops, nickels. And then the end is pennies too. I gotta do pennies, I guess, sure. If pennies not caps. If pennies now it's interesting. Okay, so I think I've got this all done here. So I'm going to actually try to print it. Oh, what? Oh, well, I'm going to try to print this and see what it does. Okay, so I'm going to try to submit this and see what it does. And it'll be interesting to see if it tests it, because it should really test it quite a bit. Oh, it doesn't like that. Okay, sorry. I guess I need an equal sign here. I don't need an equal sign there. No, I should. Oh, well, anyway, this isn't going to be, this isn't what this is. This, I shouldn't have that end thing, I don't think. I don't know why it does in my notes. Okay, so yeah, it doesn't like, yeah, okay, I'm sorry. All right, so I got to get this out of here. And get this out of here. Well, anyway, I think you have enough to fix it. See, the numbers are right. The numbers are right, but it's just spaced all bad. See, the numbers are right, and the plural, singular plural is right, but the spacing is okay. So you can fix that one. All right, leap year. Okay, this is leap year, and what we're supposed to do is we're supposed to read in a year and figure out if it's leap year or not. And this is the formula. It's got to be. This explains why we do it. And then we have here, the year must be divisible by 4. Okay, the first rule. Second rule is if the year is a century year, then it must be evenly divisible by 400. Okay, so is that it? Those are just the rules? Okay, so let's do it. First of all, it's got to be divisible by 4. So we're going to start out and say it's false. And we read in a year, if input year mod 4 equals 0, then it's a candidate. See, then it's a candidate. Must be divisible by 4. So it's a candidate. Next, we have to check this. So all right, it's a candidate. So now we say if input year mod 100 equals 0. If that's true, then it's got to be evenly divisible by 400. So if that's true, then if input year, this has got to have an underscore. Okay, so it must be evenly divisible by 400. If it's not evenly divisible by 400, then it's not a leap year. So if the input year is not divisible by 400, then it's not a leap year. It's just, it has to be. It must be. If this is true, then it must be evenly divisible by 400. Okay, so if this is true, then if this is true, then if it's divisible by 400, then it's a is leap year true. Okay, so it's got to be capital T, true. Okay, so if it's divisible by 100, in other words, if it's a century year, and it's not divisible by 400, then it's not a leap year. So this is fine. Okay, so we can end that. If the input year is divisible, if it's divisible by 4, but it's not divisible by 100, in other words, if it's divisible by 4, but it's not a century year, then it is it's a leap year. Then it's a leap year. So is leap year is true. Okay. How close am I? Okay, so this looks like this is going to compute it. I think I got this right. True. Why do I have to say false? Okay, and then I have to do if is leap year, then I got to print input year is leap year, else print input year is not, something like that. Okay, I'm gonna see if this works. Oh, I'll press that too. Okay, it looks like it's not working because 1600 is not a leap year. Okay, so I gotta, well, 1900 is not a leap year. So I got my, so my logic is wrong here. Okay, so if the input it's for zeros, if that's true, then if it's divisible by 400, then if it's divisible by 400, then leap year is true. Otherwise, it's false. Why? I thought we already. Else it's true. I'm missing something here. Oh, here we go. If this has got to be, if it's not divisible by 4, then it's not a leap. Oh no, I already said it's not to be a leap year. Huh. I don't know why. Okay, so 1900 is okay. So 1900 is, this is true. 1900, this is true. This is false. So this is not taken. It should stay false. $1,600 is not a leap year. It's expected that it is a leap year. Let's see. All right, let's step through this. So 1600 is a leap year. So what does this do? It is a leap year. Okay, so this would be true. This would be true. And this would be true. 1600 is a leap year. My output says it's not a leap year. Can anybody see what I'm doing wrong? Is a leap year false? Am I six? I have two truths. So true there, and a true there. See, I mean, I'm gonna 1600 is not a leap. $1,600 divided by 4, 0, 0, 0, percent 4, percent 100, percent 400 is a leap year. Else percent 100
Yours is done a little bit differently than I did.
Oh, wait a second. I'm sorry. Yeah, it's different, but I just noticed this. I just noticed I forgot to, there should be underscores here. Yeah, I can show you the book, what the book says too, but I think this is right. No, it's still wrong. What happened? Did you get yours right?
My internet's lagging a little bit. You said, did I get what?
Did you get your answer correct? Was your answer correct?
Yeah.
It is correct. Okay.
Yeah.
Yeah, this is different than. Okay, so
I did the I did my setup a little bit more just a little bit different. I did put for the year the 400%. I did put after the 400, I put space, and then I put 2 equal signs, space, 0. I don't know if that really matters.
Yeah. Of course it matters.
Oh, it does. Okay.
Yes. Now let's see if it works. Yeah. Okay.
Oh yeah. Okay.
All right.
There it is.
Okay. All right. Well, we don't have time for the last one. I might come back to it. It's pretty simple. So if anybody wants me to do it next time, I can. Can get some extra. Yes. There is more tutoring available. And I will find out the details, and I'll put it in an email. Okay, this is ITS128. Yes. It just got approved, and they hired a couple people, so I will get back to you on that. Good question. The question is there some tutoring available? Yes. All right. Well, good. So I will find out that information. This looks like this is going to work, and see you. I guess we're going to see you tomorrow, huh? Is there another class tomorrow? Yes, see you tomorrow. Okay. So I'll find out about the tutoring tomorrow. All right.
Will you be going over the next one tomorrow?
Yeah, why don't I do that? I didn't realize that in the class tomorrow. I'll do that.
Okay, cool. Okay, thank you.
All right. See you. Bye.
Bye.